this tells us that at most confidence levels we'll be rejecting the null hypothesis. So that kind of summarizes that. And then part 3 says, what is the 95% confidence interval of beta 1? Does it include 0? What does it mean? So this is the confidence level, or the confidence interval. So does anyone want to try interpreting what that means? Okay.
So we have 95% confidence that the slope is somewhere in between 0.15 and 0.51.
Yeah. And so
That beta 1.
that's,
So it doesn't include 0, but I don't know what that means.
yeah. So if it did include 0, that would be saying, so that would include a number, so let's say it was negative 0.15 to 0.51. So that would be saying we don't really know if training increases time or decreases performance time.
Okay.
Because if you had a negative number, that would imply that it was slowing your performance time.
Well, it depends how much of a negative number it would be. If it's just like slightly.
Yeah, if it's slightly negative, then, I mean, you'd be
it's
slightly
still
more
uncertain.
sure that it has a positive impact, but you're still unsure if it has any impact at all, basically. So if 0 is within your confidence interval, that, I mean, usually that's going to happen when you don't have a significant p-value. Because you're not sure if your beta is positive or negative, is basically what that's telling you. It's just the middle of your confidence level happens to be positive, and so that's why your coefficient is positive. But when we're dealing with such a small sample size of 20, that's kind of a big deal.
So R squared has to fall somewhere in between these two? Is R squared?
No, R squared is not related to the confidence interval.
Okay.
R squared,
Or I'm sorry, B1 has to fall.
yeah,
in between, so
beta 1
fall in
is
between these two.
always going to be the very center of those two. Okay, so it's basically saying that an hour of training increases performance time by between 0.15 and 0.5 minutes per hour of training. Yeah.
Can you say that one more time?
So this is saying that we're 95% sure that an hour more of training will increase your performance time by between 0.15 and 0.51 minutes.
Thank you.
Okay. So part C says, does the regression line look like it fits the data well? We already talked about that a little bit. It doesn't fit super well, but it fits. I mean, you can tell there's a positive trend between two variables, but it's kind of a weird string of data that doesn't look like a linear relationship. But that might be just because I generated half the numbers, and so it's weird. I don't know if it'll be like that on your problem. And then part E. Oh, so part D is what % of the variation in performance can be explained by training. So that is our R squared. So 45% of the variance in performance is explained by training. And so that means there's 55% of the variance can be explained by other things. So maybe it's, I don't know, genetics makes someone be able to last longer or do better in this factory work or something. So that's not going to be explained by training at all. Or nutrition, or the amount of sleep they got the night before, or something like that.
Other external factors.
Yeah, so that aren't included in your model.
But this answer, all you want is that R squared number,
Yeah,
45.7%, whatever.
yes.
Okay.
And then part
So,
E,
sorry, the remaining 55%, is that the unexplained variation?
yes. And then part E is if someone has 20 hours of training, what do we predict their performance time will be? So for that one, again, you're just going to write out the equation. And so that's going to be, you're going to have performance time whatever that equals is your predicted performance.
Can you say what those are again?
So this.
Not the numbers themselves, but where they came from, because it now is, there's super glare on the screen.
Yeah, so
Thank you.
this is the intercept and this is the slope.
Okay,
And so it's beta 0 and beta 1
so it's beta 0 plus beta 1 times
times,
the,
yeah, whatever you're saying the
The
training time
dependent
is,
variable.
which is
Okay.
20 hours of training. Okay. So that is the end of the problem set. Does anyone have any other questions or anything else they?
did he just throw in all these numbers randomly? Or do you think that he actually was trying to,
So I
Like-
changed the data set. So these are this is the output for the actual.
for the
problem
data set? Okay, so,
Yeah, just in case people couldn't figure out how to do it in Excel.
gotcha.
So this is
Thank
the
you.
actual output you'll be using
Okay.
when you answer the questions.
Is the data set like this in the sheet already generated, or is that what we have to generate?
No, he gives you the data in the problem set.
But you have to generate the scatter plot.
Oh, yeah, you have to generate the scatter plot.
No, yeah, okay, so this is now.
Right,
We
right.
generate that, we generate all the different.
Yeah,
data.
you generate this in Excel, and to be able to generate this, you have to download the data analysis toolkit.
From else?
No, it's just in Excel. And so if you go to File, Options, and then to add in,